Okay, we're talking about PICs here, Programmable Interface Controllers. That is the acronym that is listed in the guide, but it's not entirely an accurate acronym. We're going to go over that in a few minutes when we're talking about the history of PICs. First, a PIC, Programmable Interface Controller. It's probably not actually programmable interface controller. In doing some research, the more likely term is a peripheral interface controller. And there's a company called General Instruments back in the 70s that was developing peripheral components for computers. And computers back in the day were either huge or slow or both. So they came up with I/O controllers for monitors, for keyboards, for floppy disk drives that would control small elements of the device, but then they would communicate back with the main controller. So it was a controller for a peripheral device. So that's where they came up with the acronym Peripheral Interface Controller. Although programmable interface controller, I should say peripheral interface controller is historically accurate, but programmable interface controller is probably technically more accurate as to what the thing actually does. Basically, it's a small, low-powered, programmable computer. They take many forms, and we're going to talk about some of them. You guys have already been exposed to some of them in the form of Arduino devices. Now, one of the first ones developed by GI was the PIC 1650, and this is known as a this kind of came about to get rid of the old EEPROM technology. And EEPROM were programmable chips. The PICs were more, they could actually do processing. EEPROMs could just store data. Now this company was spun off into a company called Microchip Technology in '87, and I bring that up because aspects of that company were actually used by First Robotics to produce some of the first controllers and robotics brains for those devices. Now, describe why PICs are ubiquitous in almost all electronic products. A PIC, a generic PIC, here's the neat thing about them. They can replace hardwired circuits. So rather than having a complex, large hardwired circuit on a printed circuit board, you could just have a PIC that you program. So it's a drop-in replacement. That is, it can replace a complex circuit one for one. One PIC can replace the whole circuit. Also, a PIC is programmable. That means it's reprogrammable. That means after the device has been built and created, you can make changes to the operation without needing to rewire the whole circuitry. You just change the programming on the PIC. And a lot of times there's little sockets that are made so you could push the PIC into place and it functions perfectly normally. But if you want to make changes to it, you can actually pull it out of the socket without needing to resolder anything, put it on a programming device, reprogram it, and then put it back in the socket, and you've suddenly changed the operation of the device. There's a lot of different types of PICs that have different characteristics. So there's many different variations of the standard PIC design. And they're extremely cheap. They're cheap to manufacture, they're cheap to work with, and they're very small too. So they're green technology because they're low cost, they use low power, and they're very versatile. You can reuse them and I wouldn't say recycle them, but repurpose them for different uses. There's this thing that you've probably heard about in the news called the Internet of Things. Okay? The Internet of Things, the idea behind it is every device that you have is in some way connected. Okay? There's so many things that are out there that are on the Internet. Can any of you guys think of anything that is connected to the Internet that wasn't before?
Refrigerators?
Refrigerators, yes. There are refrigerator-connected internets. Wait. Internet-connected refrigerators. I'm not talking right here. refrigerators that are on the internet that can automatically inventory what you have in the refrigerator. So what you do is you turn them all so that there's a barcode facing a scanner, and it'll actually scan how much you have of everything. Yep.
Security systems?
Security systems are on the internet. Those have always been connected, usually by phone lines, but now they're connected on the internet. So not only calling a security company or the police, they can also message you directly rather than having to go through a third party. Thermostats, like the example here, the Nest thermostat, and there's several others that are made. My brother had one made by a different company. I think it was Belkin or something like that. It's connected to the internet, so when he leaves his house, he can turn down the energy consumption of the HVAC system, and on his way back, he can turn it back on. So he can do that right through his cell phone. Yep. Cars are internet connected now. Okay, that they can send you messages when they need maintenance, when tire pressure is low, when you need an oil change, stuff like that. So all of these devices that are on the internet now have to have some sort of intelligence to them. They have to be able to process information, take sensor data, and figure out what it is, and then send the appropriate messages to the appropriate places. That is the Internet of Things, and each one of those devices needs some sort of PIC to control it. Explain why in many design contexts only a small proportion of the PIC is used. A lot of these PICs are over-engineered. They're made to be able to do a whole lot of things. Now, when you're actually using them, most of the time you're not using nearly the entire capacity of this PIC. It could do a lot more than what a lot of manufacturers are doing with it. This gives companies a chance to release a product and then patch it to give it more abilities down the road. Okay, you can make changes to the way the object behaves by changing the programming on the interface controllers. PICs are particularly applicable in portable electronics simply because they are cheap and they use very low power. Okay, a complex circuit can use a lot of electricity, but for example, the Arduino, which uses a PIC as a programmable interface. It has powered pins. It has abstraction layer, which means it has a programming layer that you can actually understand and use. And all of this put together, it uses 40 milliamps, and actually at 5 volts isn't correct. It really uses between 7 and I think 20 is the max voltage you can put through one of those. Between 7 and 20. It'll run at 5 volts, but you're going to have some weird issues. But it's very low power. 40 milliamps is low consumption. They're sustainable. They're sustainable because you can, instead of throwing out a product and getting a new one or disposing of it some way, you can upgrade it through a software patch. Okay, changes can be made to the software, and this happens a lot with your cell phones. How many of you guys have ever went to go use your phone and looked at it and it said it needed to make an update or something like that? Happens all the time, right? Because the devices, the components that are in your phones and in a lot of devices are able to be modified. Companies actually modify them to improve capabilities or reduce power consumption, or there's a lot of reasons they do that. Also, it doesn't require very much material to produce these because they're very small, and they just use a little bit of silicone and metals, silicon and metals that are used in these things, and then they are very low energy to manufacture these devices. They don't require a whole lot of energy to fabricate these things. Explain how PIC technology has improved electronic systems and car design. Just think about how cars have become more intelligent. Just not even talking about getting them on the internet. I'm talking about like anti-lock brakes, talking about active traction control on cars, talking about climate control in fuel injection systems as opposed to the old carburetors. All of those are running using mini computers that control a lot of those aspects. So there are PICs that are used in all of these to control certain elements of the cars. If you want to see some of the applications, that link right there takes you to Microchip's website. and they go over a lot of different applications that the picks made by that company are being used in cars. Okay, we're going to switch gears here because that's kind of what the guide tells us to do. Explain how an audiogram affects an individual's hearing, which may be normal at some frequencies and with losses at other frequencies. Okay, we were talking about picks, now we're talking about hearing. So let's talk about hearing. As people age and through other factors, people's hearing becomes less sensitive to higher frequencies. We were talking about that before when I was playing that what's it called, that mosquito tone. You guys remember that? Yeah, we were playing that. And this is an example of an audiogram. It's logarithmic. So for every 10 decibels, with the way decibels work, the sound is twice as loud. So something that is, let's say, 30 decibels, at 40 decibels, you have twice the amount of movement generated by the sound waves. So it gets up exponentially loud. Now, digital hearing aids are created to help improve hearing, to boost certain frequencies. Now, the audiogram that we just mentioned actually identifies what frequencies people need to have boosted to have better hearing, and it'll actually boost just those frequencies. Now, the neat thing about it is as picks are used in these hearing aids to basically control which frequencies are boosted. The elements that go into the hearing aids, you have the microphone, you have the filters that separate the different frequency bands, analog to digital converter, which we talked about before when we were talking about operational amplifiers, processing to amplify certain and then the processor to amplify the frequency bands. Now, a graphic equalizer this is an example of a graphic equalizer on the screen right here. It is an output that shows the volume at different frequencies. Any of you guys who are interested in sound engineering, you probably are familiar with what those things are and how they work. Now, using a pick in a hearing aid, it allows these medical devices to be universal. They don't have to be custom built for every person. They can be tuned for a specific person after manufacture. And they can be tuned for a person after their hearing changes throughout their life. Okay, so they can reprogram these picks so it's more effective for the person as they age, as their hearing changes. Okay? Make sense? Awesome. So, any questions?